Hello, everyone, and welcome back to Mathics. I'm so excited because I've made another video, this time for 2020. And remember, there is no test for 2021. This is because of the COVID-19. And as usual, I'm going to go all the questions from 1 to 25. And just a quick note, um, you know that I give lessons, and a lot of parents contact me and they say, in your classes, do you only go through the questions and just do the questions and that's it? The answer is no. My main job as a teacher is to observe the student as they are doing the question. So to figure out why they can't do a certain question. And then usually it's the case that they have learned something at school, but they haven't quite learned it well. They haven't mastered it. So what I do, I just make sure that they understand it. I teach a little, and then I give a lot of similar questions, okay, in class and homework, so that they master that type of question and they feel confident, right? If I just teach them one question and go on to the next, they'll learn, but there's no guarantee that they're going to get it next time. Okay. So I just make sure that for that type of questions, they have had enough practice and they feel confident about it too. So that's what I do in my classes. So maybe for this AMC or Australian mathematical competition, for anyone you need, you could contact me and we could just set classes for you. Okay, let's do problem 1. Luca is making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar. So there is going to be sugar in it, there's going to be water in it. Which one is more? 4 times as much water. So water is more. So if we need 1 sugar, then we would need 4 times as much water. Okay, let's read the rest of it. And we need we need twice as much sugar as lemon juice. So which one should be more? We need more sugar than lemon juice. So lemon juice is going to be half of this amount. So it's going to be like 1 divided by 2. That's the only way. Sugar would be 2 times of the lemon juice. So the nice idea would be to just do the opposite. If lemon juice is 1, then sugar would be 2 times more. And we know water is going to be 4 times more than sugar. So it's going to be 4 times 2, 8. Now this is the real ratio. If you want to make, okay, lemonade, 1 lemon juice, 2 times as much sugar, and again, 8 times as much water. Now, if he uses 3 cups of lemon juice, that means lemon juice is multiplied by 3. Then how many cups of water does he need? It's going to be, because 1 has been multiplied by 3, we will multiply 8 by 3, and we know that 8 times 3 is 24. So E would be the right answer to the question. Okay, problem 2. 4 friends do yard work for their neighbors over the weekend, earning $15, $20, $25, and $40 respectively. They decide to split their earnings equally among themselves. Okay, so each person wants to receive the same amount. Okay, and to do that, so we need to find the average of all the money. Okay, that's the only way everybody will get the equal amount. So how do we find the average? We sum them all up and we divide it by the number of numbers, or the number of friends. In this case, going to be 4. And it's going to be 100 over 4, 25. So each person will get 25. This person received this question. In total, how much will the friend who earned 40 give to the others? This person needs to keep 25 It has 40. Already it has 40. It needs to keep 25, so it needs to give only 15 away to the other people. Okay, so if you give 15 away, then this person will also be 25. Okay, so we just need to give 15 away. So the right answer will be this option. Problem 4. 3 hexagons of increasing size are shown below. Suppose the dot pattern continues so that each successive hexagon contains one more band of dots. Okay, so this is important here. Now, when we want to go to the next layer, okay, look, the next layer, instead of 2, it will have 3. Okay, and if you go the next layer, so instead of 3, you're going to have 4. So to each side, 1 will be added. Okay, so, and we also have 6 of these. So this, each time one of these sides get 1 extra dot. Okay, so that's how it goes. So the pattern is very simple. The first one is 1. This one is 1 plus 6. Okay, this already has 1 plus 6. Okay, the next layer will get another extra 6, so 2 times 6. So the next one, we don't have to draw it, we'll get whatever it is here. But this 2 times 6 will get 6 more the next layer, so it will be 3 times 6. Okay, remember these 6s are common, so we could also factorize if you like. So it's going to be 1 plus 6 times 1 plus 2 plus 3. So it's going to be 6 times 6 plus 1 is actually 37. So B is the right choice. Problem 5. 3/4 of a pitcher is filled with pineapple juice. Okay. The pitcher is emptied by pouring an equal amount of juice into each 5 cups. Okay, so we're going to just pour all of this into 5 different cups, and each cup is going to get the same amount. Okay, so we need to divide this 3/4, okay, by 5. Because we're just going to pour it all into 5 cups. So we just need to divide this by 5. But do you know how to do this? Okay. All we have to do, 3/4, instead of division sign, we just write multiply. Remember, this is 5. 5 is equal to 5 over 1. So instead of this, I change the division sign into multiply. So this will instead go up. The 5 will go down. So it's going to be 1 over 5. So each cup will get 3 over 20. But because the question wants percent is, okay, in 100. So 3 over, now 20 multiplied by what number becomes 100? Okay, we want percent. So this number, if we multiply both of them by 5, we multiply 3 by 5, and we multiply 20 by 5. Remember, when we multiply something by this, we're not really changing it. So it will be 15 over 100. Okay, and of course, because here we have 100, this is equal to 15%. So C would be the right choice. Problem 6. A, D, K, M, and S rode on a small train that has 5 cars that seat 1 person each. Okay, Marin sat in the last car. So we assume we're going in this direction, left to right, then the last car would be here. Okay, and then Aaron sat directly behind S. Okay, so that means A and S should be kind of glued together. Maybe these two, maybe these two, maybe these two. So for A and S, we have these three options, okay? So a very good idea would be to assume one of them is correct and then check. So I would assume that they said like this, okay? Aaron sat directly behind S. Let's check if this is correct. Then Darren sat in one of the cars in front of Aaron. So Darren would be here, maybe. Okay. And then, so then the last person, K, will have to go here. At least one person sat between K and D. If we assume A and S are here, then there will be no place for K and D are glued together. We want them to be separated. So that means our assumption at first was wrong. So let's go back. So we know that A and S are together and Aaron sat directly behind S, okay? So Darren sat in one of the cars in front of Aaron, so D would go here and K would be here. Let's check. And then at least one person sat between K and D. Now between K and D, we have two people sitting. So all conditions are satisfied. So what does the question want? Who sat in the middle car? Okay. So remember one thing. When you see a question like this, just draw the 5 spots and just start writing. If you just want to calculate everything in your head, very bad idea. Problem 7. How many integers between 2020 and 2400 have 4 distinct digits? The digits have to be different in increasing order. For example, this number is an integer. Okay, of course. For example, a square root of 2 is not an integer. 1 over 4 is not an integer. Okay, normal numbers, whole numbers. Okay, so we know that the first digit is supposed to be 2. Okay, and the next digit, can this one be 4? Is it possible? Because we want it to be less than this, the answer is no. So these two are definite. These are forced. But here, we're going to have different options, okay? So we could have 4 here. We could have 5 here. So we need to make a list. You see that there are not a lot of numbers here. So if we have 4 as the first number, the second number could be 5, 4 and 6, 4 and 7, 4 and 8, and 4 and 9, and that's it. Okay, if this number is 4. If the next number is 5 instead of 4, then this could be either 5 and 6, 5 and 7, and you see there's a pattern here, isn't it? 5 and 8, and 5 and 9. Okay, you see here there's 5. The next one will be 1 less 4. So the answer would be 5 plus 4 plus 3 plus 2. And what is the last one? The last one would be this one 8, this one 9. So this is like plus 1. Okay, so that's the answer. We just have to add them up. 5 plus 4, 9, 12, 14, 15. So C is the right choice. Okay, problem 8. Ricardo has 2020 coins, some of which are pennies, 1-cent coins, and the rest of which are nickels, 5-cent coins. Okay, so he has at least 1 penny and at least 1 nickel. What is the difference in cents between the greatest possible and least possible amounts of money that Ricardo can have? Okay, so when we want the least, we just want to use a lot of cents, okay? So can I use all 2020, just only cents? Can I do that? This would be the minimum, right? The least. But here it says we at least need 1 nickel. So I can't use all of my coins. So I could use 2019 1. Okay. And I could have only one nickel. Okay. For the greatest would be the other way around. So I will just use 2019 nickels and I would just have only 1 penny. Now you just need to subtract. So you could calculate this and subtract, you'll have the answer. Or we could just do it some other way, okay? I could write it this way. So now, look, we have 5 2019 minus 1 2019. What's that? 2019 is common between both of these, so we could group them together. So 2019, 5, and 1. Okay, since we wanted to subtract, so it's going to be like this. And here we have a plus 5, plus 1, sorry. Okay, minus it by 5. So we could simplify it as 2019 times 4. Okay, and then 1 minus 5 is minus 4. Okay. So for the fun of it, usually, like, because you could easily calculate it. So here, what is common between the two? 4 this time is common between the two. Okay, so let's take this out. So we have 2019 4s minus 1 4. So the answer, the simplest form will be just multiply 4 by 2018 and you'll get the right answer. Remember, you didn't have to do this. You could have calculated them individually and then subtract if that's more comfortable with you. But here we could factor it out. It would be easier. So when we multiply, 4 times 2 is going to be 8,000. 4 times 18 is 72. So C would be the right choice. Okay, problem 9 is a little tricky. Most of my students get the question 1 to 8 right, but this one, they usually get wrong. And the reason is that they forget this part, no icing on the bottom part of the question. Okay, anyway, let's read and do the question. Akash's birthday cake is in the 4 by 4 by 4 by 4 inch cube. The cake has icing on the top, okay? And so that means all of this will have icing on the top. So that means all of them, okay, will have ice on the top. And the 4 side faces and no icing on the bottom. So all the sides will also have icing like this. The one behind it, this one too, like all of them will have icing. And even from this angle, they will have icing. Okay. Now, suppose the cake is cut into 64 smaller cubes, each measuring 1 by 1 inch, as shown below. How many small pieces will have icing on exactly 2 sides? So let's just go, for example, if I pick this one, it only has icing on one side, okay? If I pick this one on the corner, you'll see that it will have icing on 3 sides. You can see this one, and this one is not good. So which one has 2? Clearly this one, okay, from the top and from this part. We'll have another one over here, okay? And we know this shape has symmetry. It's symmetrical. So all of this as well. So that's going to be 8. But we also have these ones as well. Okay. So good. And there will be one over here, this one over here, and there will be one behind of it. So there's 8 here, another 8 here. But look, this one, can I write this one too? The answer is no, because it has only, the bottom part has no icing. So this one, it was 2, now it's just 1. But there will be 4 additional ones. This is what usually my students forget to do, just like these 4. This one. So it was originally 3, but because the bottom part doesn't have icing, so it's just going to be 2. So this one, and there will be 1 in the back, which we can't see, so it's going to be 4. So 8 plus 8 plus 4, a total of 20. So D would be the right choice. Problem 10. Zara has a collection of 4 marbles, an A, B, S, and T. She wants to display them in a row on a shelf, but does not want to put S and T next to one another. In how many ways can she do this? Okay, so can we write S and T like this? No. Like this? No. Okay, we have to put them away. See, one way would be to do it like this: the first spot and the third spot. Okay, so we could put S here, T here. Okay, and remember, we could also swap these. S and T could be swapped. So that's like 2 ways of putting it here. And again, so here A will go here, B could go here, or no, like B could go here and A could go here. So how many ways can we do this? The purples can swap and the red ones can also swap. 2 times 2. So that's going to be a total of 4. So I'm going to write here, we have a 4. Now, what we did was with the first spot and the third spot. Now, what if we choose the first spot and the last spot? Remember, we could go, S could go here, T could go here, or no, T could go here, S could go here. That's 2. A could go here, B could go here, or B could go here, A could go here. So you see that is again another 4. So each 2 spots you choose, that will create additional 4. Okay, so we chose this one and this one. We chose this one and this one. Is there anything else left? Yes. This one and this one will create an additional 4. That was simple, wasn't it? So the answer is 12. Problem 11, most students who get it wrong, they get it wrong because they don't pay attention that the graph is giving the time in minutes, okay? But the question is asking in hour, and that's why they get it wrong. So after school, M and N headed to the beach 6 miles away. M decided to bike while N took a bus. The graph below shows their journeys indicating the time and distance traveled. What was the difference in the miles per hour between N and M's average speeds? So the first thing is both of them go the same distance, right? This one, Naomi or N, starts from 0, ends at 6, okay? And M is also the same. It starts from 0, but it reaches 6. So both of them go the same distance, 6, but they do it in different time. So we want to know miles per hour, okay? So both of them will get 6 miles, okay? But one of them does it in 10 minutes. Okay, the other person does it in 30 minutes. Okay, there is a problem, right? As I said before, these are minutes. So 30 minutes is half an hour. So it's going to be 1/2 hour. 10 minutes, an hour is 60 minutes. So it's going to be 1/6 hour. So you would see now that because the question said miles per hour, it's miles per hour. So m goes up, the distance goes up, hour, which is time, goes bottom denominator. Okay, now do you know how to do these ones? See, remember, so a lot of people go right here 1, which is weird, okay? When I divide 6 over 6, this is 1, okay, right? But when I write 6 over 1 over 6, this is the same as multiplying 6 by 6, okay? Don't confuse them. So this one, it didn't ask you to go 6 over 2 is 3. 6 over 1 over 2 is the same as multiplying 6 and by 2. So it's going to be 6 times 2. So the first one is 36. The second one is 12. So 36 minus 12 is 24. And E would be the right choice. Problem 12 is very simple, but it looks scary. Okay, let's do that. For a positive integer n, the factorial notation represents the product of integers from 1 to n. This is just for you in case you don't know what factorials are. What value of n satisfies the following equation? Okay, so before we go and do that, do you know the answer to this? Okay, the answer to this is only 10 times 9. 90. But why? See, when you want to simplify factorials, you just have to expand them. Like this is all the way 8 times 9 times 10. Okay, this one is also 1 times 2 times 3 times blah, 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 blah. But the last one is only 8. So because all of these are being multiplied, see, if they were being added, we couldn't simplify them, but because they're being multiplied, we could go this part and this part are canceling. So what is left is 9 times 10. So that's the only thing you need to know to be able to do this question. And why do I say this question is simple? Because you have the options, right? Even if you don't know how to do it, you say, I think 12 is the answer. Okay, then you would put here 12 factorial, and then you compare the two sides. Okay, now I'm going to do it in 2 ways. First, okay, we're going to try out different numbers, but we're going to make it easier. So we're going to divide both sides by 9 factorial. Then the left side, this 9 factorial and this 9 factorial will be canceled. So let me rewrite it. The left side will be 5 factorials is equal to 12 times n factorial over 9 factorials. Now let's try a different number, okay? You try different numbers so that they're going to be equal. I'm going to go with 10, okay? So I'm going to go take this one. I'm going to guess this one is the answer. So I'm going to write 10 factorial. We just learned that 10 factorial over 9 factorial is actually 10. So I'm going to write 10 here. Now, is 5 factorial 120? 1 times 2 times 3 times 4 times 5? Yes. So my guess is confirmed. So this is the right answer. But you could also do it different ways. So I'm going to do it another way as well. So now remember, let's expand this one. 5 factorial, okay, is 1 times 2, 3, 4, 5. We just saw that this is 120. 120 times 9 factorial is equal to 12 times n factorial. Okay, so this is 12, this is 120. Okay, let's cancel them. So both sides, if I divide this one by 12, they will cancel. And because I divided this side, I should do this as well. So these two will cancel. So it's going to make a 10. So look, this is what we have. I think the answer is obvious. What is 10 times 9 factor? Remember, this was 1 times 2 times all the way to 9. And now we have another 10. Let's just put it here. So we're going to have, this will be times 10, will be equal to n factorial. Okay, and again, you see that this is 10 factorial. Okay, so we did it in 2 ways. Okay, we're going to do problem 13 in 2 easy ways. Jamal has a drawer containing of 6 green socks, 18 purple socks, and 12 orange socks. After adding more purple socks, Jamal noticed that there is now 60% chance that a sock randomly selected from a drawer is purple. So let's assume we don't add anything, okay? So right now we'll have 18 purples socks, okay, if you don't add anything. So what is the chance of selecting a purple one if we don't add anything? We have 6 green plus, okay, 18 purple. And again, it's going to be plus 12 orange. So what is the chance of that happening? It's going to be 18 over 36. You simplify it, it's 1 over 2, okay, which is going to be 50%. So if you don't add any purple, it's already 50% chance. So now it's very easy. Let's add maybe 6, maybe 9. Let's try different numbers, okay? Now, I'm going to guess from the smaller one. Since it's 50, and we just wanted to go 60, so I would assume not a lot should be added. So that's why I'm going to add 6 purple socks, see if it becomes 60%. If I go this one plus 6, remember, the total one will also increase. So it will be 24, okay, over 42. Divide them both by 6 is 4 over 7. That's not right. So this is out, okay? So let's go with the other one. I'm going to go with 9 now. This is out. If I add 9 to both sides, we're going to get 27. And this one will be 45. Dividing both of them by 9, we simplify both of them by 9. So what we're going to get is going to be 3 over 5. And guess what? 3 over 5 is actually 60%. If you multiply both sides by 20, okay, it will be 60 over 100, which means 60%. We got it. Okay, so 9 is the right answer. So can we do it using an equation? Of course. So remember, like we added 9, right? We kind of guessed it. How did we guess it? Because the question gave us some options. But if you don't know, so you just have to put here x's. Instead of 9, you just put x. And then you would solve it. You put x here, you put x here, and you say it has to be equal to 60%. Right? This is how you solve it. We simplify this to make it easier. That would be 3 over 5. Okay, and from here, we have to do a cross multiply. I will just multiply 18 plus x multiplied by 5. So I'm going to write it here. 5 times 18 plus x has to be equal to, okay, 3 times this. This was 36 times plus x. 3 times 36 plus x. How did I get this equation? Okay, I cross multiply. these two together, 5 and 18 plus x, 3 and this one all together. This is how I found it. So now let's multiply. We're going to get 90 plus 5x is equal to 108 plus 3x. Okay, so we're going to get 2x is equal to 18. We'll divide both sides by 2, so x will be 9. So it's actually the same strategy, okay? But because the question is giving us options, why not use that to our advantage? We just get so much faster. Well, if you know what to do, this question is actually easier than question 5. Really, really easy, okay? So all you have to know this. So if I ask you to find the average of 1, 3, 5, 9. Okay, how do you do this? Okay, you would go 1 plus 3 plus 5 plus 9. This is what you do, right? Okay, and then you divide them by 4. So it's going to be 4, 9. 18 is going to be 4.5. Okay, right? This is how you do. Now, this question is asking for the sum of the numbers. When it's asking what is the total population, that means add this one and then plus 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 this one. It's going to be just asking for this. Okay, this is 18, right? But instead of doing this, which takes a long time, okay, if I multiply these two numbers together, I get that 18 again. So instead of adding all these numbers, I'm going to multiply these two numbers. This is the average of them. This would be like the number of the cities, okay? So 4 times 4.5 is 18. So we're going to use the same principle, and that's going to make the question really easy. Let's read it. There are 20 cities in this city. The populations are shown in the bar chart below. The average population of all the cities is indicated by the horizontal dashed line. So that's going to be the average. Okay, remember, that was like, we had 4 numbers. We have 4.5. This is like the 4.5. Okay. Which of the following is closest to the total population of 20 cities? So this 20 cities is like this 4. So we just have to find this average and multiply it by 20. So we have 20 cities multiplied by this number. Okay, so what is this number really? This will be 4 or 5,000. This one would be what? Exactly between the two. So I'm going to have a 5,000 here. So between the two is going to be this, which is going to be 4,500. And what is between them? Is again a number that is between 4,500 and 5,000. Exactly in between is what? It's 4,750. So we just have to multiply these numbers. 4,750. Okay. So when you multiply these numbers, you're going to get 95 and 3 zeros. Okay, 20 times this number. So there you go. D is the right choice. Now, to do this problem effectively, you just need to be able to turn these percentages into fractions. Okay, so 15% of x, 15, we know that 15% is going to be like this. Let me make it larger. So 15% of x is equal to 20% of y. Okay, so this is what the question says. Okay, now what does the question want? What percentage of x is y? Probably this is the most critical part of the question. Let's read it backward. y is, so I'm going to write it like y is becomes equal sign, is what percent of x, okay? So it's going to be something like this, what percent of x. So that means we need to have y alone, okay? And then get the number just behind x, okay? That's how we're gonna do this question. So you would see here, y has to be standing alone, right? So to do that, so do it any way that you can, right? We just want y to be alone. There are just like thousands of ways to do it. Now, can I simplify this 100 by this 100? What do you think? The answer is yes, I can do that. The reason is we could multiply both sides by any number that we want, and things will be no different. And I could also write it this way. So this 100 goes with this 100, this 100 goes with this 100. So anyway, so we know that the next line here will be 15x will be equal to 20y. Okay, now remember, okay, y, we want y in this form. So let's divide both parts by a 20. This part by a 20. Because we're dividing the right hand side, we should also do the left hand side. And look, this 20 will cancel with this. Okay, so we're gonna have the next line of the equation will be 15 over 20x is equal to y. And this is exactly what we needed. So now let's compare this part of the question. What percentage of x? The answer is like that. But we need to take this into percentages, right? So to do that, the denominator has to be 100. So 15 over 20, I'd like to do purple again. So 15 over 20, okay? If we multiply both of them by a 5, then we're gonna get 75 over 100. And 75 over 100 is actually like 75%. So you'll see that this is now the answer. So C is the right choice. This problem 16, is almost difficult for all my students. I think this is partly because even understanding the question is challenging. Okay, let's read the question first. Each of the points A, B, C, D, E, and F in the figure below represent a different digit from 1 to 6. So for example, A could be what? Maybe 1, maybe 2, maybe 3, and so on. Each of the 5 lines shown passes through some of these points. Okay, obviously. Good. So the lines are passing through the points. Okay. The digits along each line are added. This is the most important part. The digits along each line are added to produce 5 sums. Okay, so for example, this one will give us A plus B plus C. Okay, that's one line, so one sum. And then, for example, this one, there is another line, B plus F. Okay, that's another line, another sum. So because we have 5 lines, of course, we have 5 sums. The total of the 5 sums is 47. What is the digits represented by B? Okay. Now, what is each sum? Okay. Now, for example, A is passing through how many of these lines? Look. So 1 line and 2 lines. So when we are adding all the sums together, A will be repeated 2 times. Okay, so in the final one, so we're going to have 2A. Okay, so F is passing again 2 lines. E is passing 2 lines. D is passing 2 lines. C is passing 2 lines. But B is special here. Okay, B is being repeated 3 times. Okay, that is what makes B unique. It's 3 times. So I'm gonna go write this. Each one, B is 3 actually. So 2C, I'm gonna write it like this. And 2D plus 2E and plus 2F. And I'm gonna write F, 2F here. And plus 3B is equal to 47. Okay. Good. So how to deal with this? Okay. Now we have this equation. This number here is even or odd. This is odd. Okay. So these numbers, if A is odd, but what is 2A? Because it's being multiplied by 2, it doesn't matter if A is odd or even. 2A is always even, just because we're multiplying by 2. So the same story with this. As you see, all of these are even, and even here. Okay. So when you add even numbers, like 2 plus 4, 6, again, it's even. Okay. But how can you do that? Now, even number is becoming odd. That means 3B is odd. So if 3B is odd, can B be even? Like, for example, let's just assume a number here, like 15, for example. 15 is odd. 3, then B is 5. B is also odd. So we're just doing all of this to know that the answer to B, okay, is either all the odd numbers here. Maybe it's 1, maybe it's 3, maybe it's 5. So we know it's not even. Okay, so now we just have to replace each value to see if it works or not. So what do I mean by that? Now we just need to plug in the values of B equal 1, 3, or 5 into the equation and see if it provides a solution. Okay. Remember, all of these two are similar in all of them, so we could take it out. Okay. Let's factorize it. It's going to be 2 plus everything here, all the numbers, all the digits except B. So it's going to be A plus C plus D. So we know it could be all the numbers here. So let me clear it. It could be all the numbers here. 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, and then we're going to multiply by 3B. Whatever we choose for B here, it will be omitted from this part. Now, let's see. For example, if this one is 1, if this is 1, then 1 will be omitted from here, crossed. So let's see if it works. 2 plus 3, 5, 9, 14, 6, 20. So all of this will be 40. 40 plus 3B, B was 1, it becomes 43. It's not going to work. Let's try B is equal to 3. So if B is equal to 3, 3 will be excluded from here. So we're going to have 1 plus 2, 3, plus 4, 7, 12, 18. This will be 18 times 2, 36. This will be 9. It will be 45, 2 missing. So then the answer has to be 5. So this is also, we know it has to be odd. And the only number that could work is here. This is the answer. let's just try it, okay? So if b is 5, then 5 will be excluded from here. 1 plus 2 plus 3, 6, plus 4, 10, 16, times 2, 32. And this will be 15, 3 times b. It is actually 47. So as you see, b equal 5 is the right choice. Now, problem 17 is also challenging to most students. How many factors of 2020 have more than 3 factors themselves? Okay. As an example, 12 has 6 factors. This is just in case you forgot or you don't know what factors mean, okay? Not very important. Good. So what is the first step when you receive a question about factors? Okay, and all similar questions. You just need to do prime factorization. You need to write this number as multiplication of some primes. So there is a 0 here, okay? We know that 0 is actually 10. So this part is actually 2 times 5. I'm going to write the 2 multiply 5. And then I'm going to do prime factorization of 202. Okay, we know that this is 2 and 101. This is also a prime number, okay? This cannot be divided into any other numbers, but just one end itself. So here, I need to multiply it by another 2, so, and 101. So it's going to be 2 squared multiplied by 101. Okay, that's the first step. Now, the next step is, right, how many factors does this number have in total, right? It's very simple. Like there is a simple formula, okay? Look, 5 is to power of 1, 101 is power of 1. Okay, look. So I take this number 2, I add 1 to it. I take this number 1, I add another 1 to it. I take this 1, I add another 1 to it. So 1. It's going to be 3 times 2 times 2, 12. So this number has 12 factors, okay? So now that we're going to list it, okay, if we just count 11, that means we forgot to write one of them. So if you have 12, that means you have made the complete list, okay? So let's go and write down all the 12 factors here. So obviously 1 is 1 factor, obviously 2 is, 2 squared, 4 is another one, 5 is, okay, 5 and 1 of the 2, 10 is, 5 multiplied by both of these is 20, is, okay, now the next number will be 101, okay, 101 multiplied by one of the 2's, 202, by both of them, 4, 404, by one of the 5's, okay, 505, that doesn't look good, 505, multiplied by 10 is going to be 1010, and all of them is going to be itself. So now, if I count them and it's 12, that means I didn't skip any. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I know that I have a full list, okay? Now what does the question want? How many factors have more than 3 factors? So 1 has only 1 factor, out. 2, 1 and 2, out. 4, it has 1, it has 2 and 4. It's 3, but we want more than 3, out. 5, 1 and 5, out. 10 is good. It could be 1, 2, 5, 10 is 4. So obviously 20 is 10 times 2. If 10 is, then definitely 20 also is. Okay, so 105, only 1, and 105, 1. So this is out. We have to check this one. 1 is, 2 is, 101 is, 202 is. So it's got a 4. Okay, so this one is good. If this one is the answer, obviously this one, this one, this one, and this one, all of them are, they have more than 1. But the factors here. So all of them except these 5. We had a total of 12. 5 of them are out. So 7 remain, which would be this option right over here. Well, usually over problem 18, I have a conflict with my students. They say this one is difficult, but I say it's very easy. So you watch the video and say which side you're on. Well, rectangle ABCD is inscribed in a semicircle with a diameter FE. As shown in the figure, let DA be 16, FD is equal to AE is equal to 9. So all of them are written here. What is the area of ABCD? Okay, so to me, it's obvious that you have to draw this line. Why is it obvious? Because this happens in all the questions. Like when you inscribe something, okay, in a circle. So you always do that. You go from the center to any points of intersection, right? So you most of the time you have to have, okay, this is equal to this is equal, this is the first thing you do. Okay, it's not I am creative and I draw this line. We always do. Okay, and so we always know that around problem 18 we're going to have a Pythagorean theorem question, like 18, 19, 20, 21, 22, like they always use that. So it's kind of obvious. So here we know that, okay, this is a right triangle. So trigonometry. Okay. And here it says from, okay, now we know from AD is actually 16, all of this. And we know that the center is actually in the middle because this, if you inscribe it, the picture will go exactly in the middle. So that means this part is 8. So you tell me, what is the radius? Okay, from here to here, 8 plus 9, 17. So this is also 17. This is also 17. This is also 17, right? Okay, so this is 17, right? This is 8. So what is this one? A lot of people have this already memorized, okay? This is obviously 15. Memorize it, like 8, 17, 15. Or if you don't have this memorized, we know that a squared plus this side, I'm going to call it like a question mark. Question mark is squared is equal to 17 squared is 289. You minus that, question mark squared is 225. And the question mark will be 15. So come on now. We just have this side of the rectangle is 15. This side is 16. You just multiply them and you get 240. So who's right? This is really easy. But if you find it difficult, well, what does that mean? That means you haven't done enough questions, enough similar questions, right? If you struggle with this, that shows lack of practice. Okay, you need to do more. Problem 19. If you understand the question, I think you will get the question right. Let's read it and understand it. A number is called Flippy if its digits alternate between two distinct digits. Okay, alternate is like this, like 0, 1, 0, 1, 0, 1. And why does it say two distinct digits, right? For example, you can't go 4 and 4, 4 and 4. Like this number is not possible. Okay. So for example, 2020, 2020, and 37373 are Flippy, but 38, again 3. So that's why it's out. 1, 2, 3, 1, 2, 3 is alternating, but it's 3 digits. We just want 2 digits. So this is out. How many 5 digits Flippy numbers are divisible by 15? Okay, so I hope you know that if you want the number to be divisible by 15, it has to be divisible by 5 and it has to be divisible by 3. If you want the number to be divisible by 5, that means this number here should be either 0 or 5. Can this number be 0, however? Because it says alternating, this has to be 0. This one also has to be 0. But if this one is 0, then it will be a 4-digit number. So it's not going to be acceptable. So that means this number has to be 5, this number has to be 5, and this number has to be 5. Okay. Now, so which numbers can you put here? You just have to try it. If this one is 1 and 1, okay, is that divisible by 3? See, 5 plus 5 plus 5 is 15 plus 2, 17? No. So which numbers are? Look, these numbers 5 plus 5 plus 5 is already divisible by 3. So I need to put these numbers because we're going to have 2 of this. Okay, so 2 ones will not work. It becomes 2. If I put 2 and 2, it's going to be 4. No. But if I put 3 and 3, because 3 is already divisible by 3, 2 of them, 6, is also divisible by 3. So, okay, what numbers will work here? 3 and 3, 6 and 6, 9 and 9. So you just have to be extra careful here. I said 5, 5, 5 are already divisible by 3. So if I go with 0, 5, 0, 5, this number is actually also one answer. It's divisible by 3, it's divisible by 5. So that makes a total of 4. So B is the right choice. Okay, problem 20 provides a good teaching opportunity. Okay, let's learn something new as we do this question together, right? If you have read this question, okay, you know that this is also a great clue in solving this question, okay? And we're going to learn something right over here. But before we do, let's read this question together. A scientist walking through a forest recorded as integers the height of 5 trees standing in a row. Okay. She observed that each tree was either twice as tall or half as tall as the one to its right. Good. So that means when I go to the next tree, it should be 11 divided by 2 or 11 multiplied by 2. So 11 divided by 2 will be 5.5, but the question says they have to be integers, so 5.5 is out. So that means the one before it, okay, was 22. Then it was divided by 2. Okay, and then it will be multiplied by 2 because 5.5 is not possible. Good. So unfortunately, some of her data was lost when rain fell on her notebook. Her notes are shown below with blanks indicating the missing numbers. Based on her observation, the scientist was able to reconstruct the lost data. What was the average height of the trees in meters? So we want the average. We have 5 trees. We're going to add all of them divided by 5. So the teaching opportunity that I said. So what is 1 divided by 5? 0.2. Okay, right. 2 divided by 5, 0.4. 3 divided by 5, 0.6. 4 divided by 5, 0.8. 5 divided by 5, okay, is going to be actually like 1. So it's going to be like 1.0, okay? It's not going to have any leftovers. Okay, but Now, the idea is, what happens if I add 1 to this number? What is 11 divided by 5? See, it's going to be 2.2. What if it's now 21 divided by that? It's going to be 4.2. You see that always this will be the same, okay? As long as the units digit is 1. Okay, so 2 divided by 2. Now what is 32 divided by 5? It's going to be 6.4. So you would see that, okay, the units digit will decide if it's 0.2, 0.4, or which number. So since this is 0.2, we know that the number should either be 1, like 11, divided by 5, or it could be 16. When you divide 6 by 5, it also creates 0.2. So with all this information that I said, we know that the sum of these numbers should be having, okay, maybe 1 as the unit digit or 6. These numbers, they could be anything. It could be, for example, 81. It could be 86. It could be 101, 106. But we're so sure of this too. Okay. So with this in mind, after here, we have two choices. The next one could be divided by 211, or this one could be multiplied by 244. Okay. If this is 11, the next one has to be 22. Okay, no other way. So let's check this one. If this is 11 and this is 22, we're not going to add all of them. We're just going to go with the units digit. 2 plus 1, 3. Plus 2, 5. Plus 1, 6. Plus 2, 8. Is that going to work? No. When you divide it, you're going to get 0.6. So this is out. So after 22, if it's not 11, we checked 11, then we have to check 44. Now look, let's just go with these. 2 plus 1, 3, plus 2, 5. So this is already 9, okay? If I write here 88, this 9 and 8 will give 17, 7. It's going to create 0.4. We don't want that. So, but if I write here 22, it will create a 6 or a 1. 2 plus 1, 3, 5, 9, and 2. Okay, so we know it's going to create 11, so the units digit will be 1. So this is the right answer. So you add them all up, okay, you're going to have 11 11s. So it's going to be 121, the sum of all of these. So we just have to divide it by 5. Okay, 120 divided by 5 is 24. 1 divided by 5 is 0.2. So there you go. So this would be the right choice. Well, this problem 21, provides a great learning opportunity, and let's just use that. So for now, we're not actually going to focus on this table, okay? Instead, we're going to focus on this grid that I've drawn here. So if I ask you how many ways can you go from this point, for example, to this point? Okay, but given that you could only go right or up, okay? You can't go left. You can't go down, okay? So that means the shortest path possible, okay? The shortest path are going to be like 1, 2, 3, 4 only. But if you can go left and down, it's going to be like this. You could always go like this. No, this is not allowed. If you take the shortest path, that means you only go right and up, and you want to go from here to here. How many ways are there? Okay, so first we need to learn this. Okay, so to get to this point, we're going to be like this. To go from here to here, the shortest path is only one way. Because if you go like this, that's not the shortest path. So one way. To go to this point, Again, the shortest path is just one way. To go to this here, 1. The same here, 1. And we don't need to calculate this because we don't want to go up. Now, how many ways is there to go from here to here? That's going to be 2. Maybe like this. Maybe like this. So I just have to add these 2 points that lead to this, right? From here to here, 1. From here to here, 2. Okay. Now, how many points are there to go from here to here? Okay. So the leading number, the one that is connecting to this, there is 1 here. There is 2 here. So it's going to be 1 plus 2, 3. So I'm going to put here a 3 here. Okay. So the same way here, this is 1, this is 2. Okay. So for this point, I have to go this point and this point. I add them up, it's going to be 3. So for the last point, the middle point, 3 and 3 is going to be 6. So the answer is 6. There are 6 ways to go from this point to this point. Okay. Now, what if I ask you this? Okay. So it's going to be, for all of these points here, it's going to be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. This one will be 2. This one, look, for this point, we have to add this and this. So it's going to be 3. For this one, we have to add this one and this one. 4. They're 4-way, they're 5 ways. Okay, here. There's a 3. I'm adding these 2. But look, for this one, I have to add 6 and 6. 3 and 3, 6. For this one, 10. Okay. For this one, 10 plus 5, 15. So you see now, we just have to keep adding them this way. For this point, to get to this point, we can go from here or here. So 3 plus 1, 4. Okay, and then 10. Okay, and then here 20. And then here 35. Okay, so you just have to add all of these points. Let's just complete the grid. So this will be actually 5. This would be 15. Okay, this would be again 35. This here will be 70. Here would be 6, 21. Okay, 56. And the last one is going to be 56 plus, okay, what was that here? I think that was 70 here. Okay, but it's not really important. The idea here is important. Okay, so this question problem 21, is a different version of this question that many of you are familiar with. Okay, so now let's actually go and deal with the same problem. Okay, to clean all of this, let's go and focus on this. But before doing that, let's just read it. A game board consists of 64 squares that alternate in color between black and white. Black, white, black, white. The figure below shows the square P in the bottom row here, okay, and a square Q in the top row. A marker is placed at P. Step consists of moving the marker onto one of the adjoining white squares in the row above. Adjoining, okay, is close to the word adjacent, like it's a neighbor, okay? So you just have to go through the whites. You can't go and use blacks. So you can't go up, okay? You can't go like this, no. Only through whites. How many 7-step path order to 4 there from P to Q, okay? So basically, we're just gonna use the principle that we learned together, okay? So from this point to go to here, there's only one way, okay? To go to this point, again, there will be one way, okay? Do I need to calculate the ways we could go here? No. Okay, we can't go far. Okay, we just want to go shortest path. So how many ways are there to go to this point? If I go here one way, then I have to go here, the same one way. So this will also be 1. Okay, the same idea here. So there's only one way to go here. So this will also be 1. But for this one, we just have to add the 2 lower point numbers, like these two. It's going to be 2. And you see why? Because one way like this. So obviously it's 2. Okay, now, again, we could go like this. That's one way. Remember, there were like 2 ways to get to here. Okay, so this will be 3. Let's just look at the 3. This is one of them. This is the 2. And from here to, see, this is 3. So how many ways to go here? If we have 3 ways of getting to here, so to go from here to here, we could only access this point from here. Because this one is 3, this will also be 3. Okay, now for this one, I can't write this one yet. Because to get to this one, I need the number for 3. And I need the number for this one. I don't have this one. Let's go and calculate that one first. So this is 2 plus 1, 3. 3. So you see that I just add these numbers over here. Okay, so 6 plus 3, this is going to be 9. For this one, 2 white squares are adding up to it. This one and this one. I don't have this one. Let's go and find it. So to find this one, I also need this one as well. So let's find that one again. So here, if there are 3 ways here, so from here all the way, there will be one way, shortest path. So from here to here will be 4 ways. So 4 plus 6, 10. Okay, so from here to here, this one is only accessible from here, so 9 again will be repeated. This one, we could access it from here or here, so we need to add them. 10 plus 9, 19. And finally, we just have to access Q, you have to access maybe from here, maybe from here. There are 19 ways to go here, and there are 9 ways here. So to go to Q, we just need to add them again. So it's going to be, the last one will be 19 plus 9. So it will be actually 28 ways. Okay, this is the best idea to do this problem. There are other ideas. But the reason I started with the grid was that, you see, okay, it's not like a brand new question, okay? They just put it on a game board, like, so that you don't think, it's a great question, because a lot of people see the grid, they just quickly and write it down. Okay, so the answer is 28. Now for problem 22, if you understand the question and you're careful and cautious, then you can manage this question. It's not that difficult. So let's just read it. When a positive integer n is fed into a machine, the output is a number calculated according to the rules shown below. So for example, if the number, for example, is 10, what happens if you feed 10 to it? If it's 10, it's going to be divided by 2, will be 5. Okay, but if n is odd, like for example, 5, okay, it's going to be multiplied by 3 plus 1 is going to be 16. Okay. For example, starting with an input of 7, the machine will output this number 22. Then if output is repeatedly inserted into the machine 5 more times, the final output is 26. So for example, we put 7 here, this will become 22. We take 22, put it here. Because it's an even number, then we divide it by 2. 22 divided by 2 is 11. So the next number is 11. We take 11 again into the machine. This time is odd. So we have to multiply it by 3, and then we have to plus it by 1. It's going to be 34. Okay, so we take it here in, so you see the idea. Okay, right over here. Now let's just keep reading the rest of the question. So when the same 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers n? Okay, so for this problem, we have to find all values of n, right? So if we just find some of them, that's not enough. And we have to make sure that we have found all of them. So when we look at this number, we know, so it was only 2 was only possible. And then we go back, so we know it was 4. Okay, but we need to make a bigger list, okay, of all these odd numbers first. So now if n is 1, we're going to get 4, okay? And we can't put 0 here because here it says positive integer n. Okay, so if it's 3, it's going to be 3 times 3 plus 1, 10. If it's 5, 16, okay? If it's 7, 22. If it's 9, 28. If it's 11, 34. If it's 13, 40. If it's 15, 46. Okay, so you could also see that here, each number is being plus by 6, right? You get the idea here, so we don't have to calculate that way. So the next one will be like 52. Okay, so this is important. And the next one will be 58. And the next one will be 64. Okay, now why it's that is necessary. So if we go back here, so I'm pretty sure everybody who understood the question found this one, right? They found 16, then you find 32, and then you find 64. Okay, so 64 is one obvious value for n. And I think you have found it. So 64 is here. But when we go back, okay, so if any of these numbers, look that I wrote it only up to 64. I didn't continue it because of the 64. Now, once we are going back, if we encounter any of these numbers, so now we encounter 4. Okay, and 4 was made by the value 1 here. So then I know, this could also be 1. Okay, or if I continue the same way, if I put 8 here and 16 here, I have 16 here. What value of n made 16 here? It was 5. 5 times 3 plus 1. So going back from here, this could be 5. Now we can count all of them. So the other possibility here was 4, here 1, then 2, then 4. Going back one more time is going to be 8. Yes, so I just put 8 over here. There was one more. So we go back here 8, we go back 16, and because 16 is here and we made it by 5, so we jump back to 5, and the last one was 10. So now we're pretty sure we have found it all. We just have to add them all up. 74 plus 8 is going to be 82. Okay, let's do problem 23. And I personally think this problem is even more difficult than 24 and 25. I think this is the most difficult for this test. We have 5 different awards. We have a PlayStation, Xbox, iPhone, APP apple and oranges as presents. And we have 3 students. Ali is my name, Bob, and the last person is you, whoever is watching this video. Okay, now each of us, each student will receive at least 1 award. In how many different ways can the awards be distributed? So when we see this, of course, you have no clue at first. Like the first second, no idea. So you have to play with the question a little. Say, okay, so each person gets 1. So for example, let's give myself PlayStation. I'll give you an Xbox. Okay. We have to just play with the question a little. So, and then there will be 3 more for this Bob person, right? So there's possible to have 1, 3, 1, okay? And the question says nobody can be 0. So I will ask you, is it possible that I give you 4 items, like 4 awards? Then if I give you 4, there would be 1 for me and 0 for Bob. Not possible. Okay, so the maximum present or award somebody gets is 3, and then the other 2 people had to get 1, 1, 3. Okay, is there another way to distribute these items? The answer is yes. Maybe I get 2 awards, you also get 2 awards, and Bob get 1. Okay, so we have these 2 ways of distributing the items. Can we count all of these together at once? No. So we need to break this 1 question into 2 questions. Not 1, 2 questions. So that will be like question 1, question 2. Okay, and then we add all these combinations that we make. Okay, so the idea here, we call that casework. Okay, so now let's go with 3, 1, 1. Okay, we're gonna just find this. Okay, so let's do that. Now, you see here, Ali, Bob, you. Okay, there's only 1 person who's a special here. The person who gets 3. The people who get 1, well, they're not a special here. So how many ways can we select a special person? Maybe Ali becomes a special, gets 3, me. Maybe Bob does, or maybe you do, okay? So that's 3 ways. So I'm gonna write 3, multiply. Now, imagine I choose you to be the special person, okay? And then you have to get 3 of these awards, okay? How many ways is to select 3 awards from these 5? So it's going to be combination of 5 and 3. Okay, how do we calculate combination of 5 and 3? Let me explain real quick. You will write 5 factorials here, 3 factorials here, and then you minus them. 5 minus 3, like this, becomes 2. This one also factorial, so it would be like 5 factorial divided by 3 factorial divided by 2 factorial, something like this. Okay, if you still don't understand why combinations are like that, then you need to watch and learn about combinations and come back and watch this later. Okay, so now we selected 3 items from the 5 items, okay? So, for example, let's give you, the special person, Apple, oranges, and iPhones, okay? For Ali and Bob, PS and Xbox are remaining. So I could get the PlayStation, the other Bob Xbox, or I could get Xbox and the other person PS. So that would be another 2 ways for this one. Okay, so let's just review. This trip was to choose who's the special person. In this case, you got the special person. How many ways to select 5 items from 3 items? And for Ali and Bob, there's still like a 2 possibility. So this question, part 1, is actually solved. We just need to add them all up together. So what is combination of 5 and 3? I just wrote it. So 3 times 2 is 6. Combination of 5 and 3 will be 5 divided by 3 factorials. This is going to be 20 divided by 2 factorials. So that's going to be 10. So this will be 6 times 10, 60. So the answer to the first part of the question is 60. This was the easier part. Okay. So now question 2 will be like, or case 2 of this one is 2, 1, 2. Now, who is a special in this case, right? The special person in this case will be the person who gets one item. You could get one item, Bob could get one item, or Ali could get one item. Okay, so how many ways to choose that unlucky person? Again, 3 ways. So question 2 will be again like this. Again, we choose the unlucky person. Then the unlucky person will just have to get one of these items. Okay, let's give that person oranges, for example, because that person's already unlucky. So from these 5 items, how many ways? Of course, 5. Maybe oranges, maybe Apple, maybe iPhone, maybe Xbox, maybe PlayStation. I could also write combination of 5 and 1, which is actually 5. 5 ways of doing it. So, and then, so we have 4 items, okay? And so let's see, we give Bob oranges, right? So how many ways to give PlayStation, Xbox, iPhone, and Apple between you and I, right? This would be combination of 4 and 2. There is only 6 ways of doing this. Combination of 4 and 2, if you write it, is going to be 6 ways only. Okay, so, but let's see why this is only 6 ways. Okay, so we already said there are 4 items left. Let's just do it 6 ways. 6 ways is not a lot. So Bob is out. We gave Bob oranges. And there are like, so how many ways to just distribute this? I could give myself PlayStation and Xbox. Then automatically the other 2, so I'm going to write it with just the first letter. I give myself PlayStation and Xbox. You get iPhone and Apple. Or I could get myself PlayStation and iPhone. Okay, you get Xbox and Apple. I could get myself PlayStation and Apple. You get Xbox and iPhone. Okay, so you just see it here. You just can't continue yourself. So if I could get Xbox and iPhone, okay, you get PlayStation and Apple. You continue this, there's just 2 more. So that's only 6 ways of doing this part over here. Okay, so we just have to multiply this over. So this is 6, this is 5. 6 times 5 is 30. Multiply by 3, 19. So now we just need to, the questions, we broke it into 2 cases. We just need to add them together. 60 plus 90, 150. Well, B is the right choice. Well, I've done this problem 24 with a lot of students, and I just see it that every time they struggle with understanding the question. Okay, so now let's go and read it, see if we can understand it well. A large square region is paved with n squared gray square tiles, each measuring s inches on a side. So here the question is just saying from here to here is s. Okay, so that's what it says. This is s now. Okay, and a border, and this is the problematic sentence, right? And a border d inches wide, there is a border and it's going to be d inches wide, okay, surrounds each tile, right? So this is, for example, one tile, and what is the border that surrounds it is this, okay? And the border is how long? Is d inches long, okay? So that means, okay, if this is s, okay, so now from here to here would also be d. I'm going to show it here, but all of them are equal. This is also d, 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 okay? So we have s and we have d. The figure below shows that case for n3, okay? This is not the actual question. They just made the question a little easier by visualizing it for us. When n is 24, okay, so first you have to know, what is this number? This is n, we have taken and put it here. So this is really 24 squared, right? So we just know that because that's what you're going to need that. Gray tiles cover 64% of the area of the large square region. So that means if we have to add all these gray ones together, okay, and then we divide it by this one, and it will be a fraction, which is 64 over 100. So if you pay attention, even these numbers, right, they have been chosen like they're very special, right? Because 64 is 8 squared and 100 is also 10 squared. See, everything here is in square form. Okay, so now let's go and write it. So we know that there's going to be a fraction. The smaller areas will be 64 over 100. Okay, so we just have to add all of these smaller pieces. Okay, let's do that. How many of them do we have? Okay, in this case, it's 9 in the picture, but in the actual number is 576, which is going to be 24 squared. I'm going to write it this way. How many of these small ones do we have? 24 squared or 576. Now, what is the area of each one? Well, simple. These are a square, and we know that this is S, so S times S. So the numerator, the top part, over. So we just need this part. Okay. Now, this is the 3 version, like n is 3. When n is 24, we're going to have how many s's? Now we have 3. We have 3 squares, 3s. We have 24 squares, we have 24s. So it will be 24s. So, but you see that we're going to have some pieces together. I'm sorry. Okay. I have allergies. So we're going to have 24s. And how many of these pieces over here? Look, when we have 3s, well, how many of these do we have? 4. The number of these will always be 1 more than the number of s. So here we have 3, but we have 4 of these. So when we have 24s, we're going to have 25d. So this side, okay, we wrote it in terms of s and d. That's it. So we know that to get the largest square area, we need to multiply this by this. Since it's a square, well, this is also 24s plus 25d. That's it. Okay. So I'm going to go here, right? 24s. It looks bad. 24s plus 25d. D actually. Okay. And all of this is squared. This is over. Now, it is no longer a geometry question. That is an algebra question. Okay, so we don't actually need this thing anymore. So I'm going to hide it. Okay, so this is an algebra problem. So you see that now everything is in a square form. 24 squared, s is squared, this is squared. And we could write this as 8 squared. This is also 10 squared. Okay, so what do we need to do? We need 2 large square roots. One for this part, the other for this part. And when we do that, we get rid of all these 2's. So we're going to have 24s. And we're going to have 24s plus 25 d. And this side, this was 8 to the second power. So power 2, cancel. Will be 8. This will be 10 over, isn't it? So now we could also simplify it a little. So dividing both by 2, 8 divided by 2, 4, 10 divided by 2, 5. So this is actually 4 over 5 now. So it's very simple. How do you get rid of this? By cross multiplying. So these two first, you multiply them together. And then later we multiply these together and they have to be equal. So let's go. 24 s times 5 is going to be 120s. Okay. So, and then I apply the equal sign. So now 4 times of 24s plus 25d. Okay. So again, let's go here. This would be 96s. So this side will be 100s minus 96s is equal to 25d. Okay, so it's going to be 24s. Sorry, it's going to be equal to 100d. I made a mistake. Let me undo that. Okay, good. So we just have to simplify this. I cleared this now to have some space. Okay, so we're going to have 24s is equal to 100d. So look at the options now. It would be the small number over the big number. So it's going to be 24 over 100. Do we have 24 over 100? No, because it's not been simplified yet. So we could divide them both by 4. So this by 4 and 100 by 4. So you see that is going to be 6 over 25. This question is a little long, right? But we did it. Well, problem 25 is a little scary looking. It appears difficult, but it's actually not very difficult. Let's just read the question. Rectangles R1 and R2, we see in the picture, and we have 3 squares shown below combined to form a rectangle that is of these 2 units, okay? So now you just need to know these numbers. We don't care about the numbers. Well, the difference between the 2 numbers are actually important, okay? What is the side length of S2 in units? So that would be like, it's asking for the value of B, exactly in the middle. Now, let's see it here. So obviously, this longer side is from here to here, is this number over here, which is going to be A plus B and plus C. Okay, easy, right? So I'm going to write that A plus B plus C is actually equal to 3322. Good. So now, what should we write for the other part, right? For this side. Look, this part is already C. Okay. But this part, we don't have it. Okay. You just have to see, you have to write this in terms of A and B. So what do I mean by that? Okay. So from here to here is actually also A. Let's just highlight it. This is A also, right? This is also B. Now, what is A minus B? So from A, remove this part. So imagine from A, you remove this part. This portion will be left. So this portion is A minus B. Okay, so this part would actually be A minus B. There you go. So this side, this length was actually 2020. So we're going to get A minus B plus C is actually 2020. Okay, now remember, we just want to find the value of b, and we no longer need this picture. Okay, it's no longer a geometry question. So it's just, again, like algebra question. So I'm going to, okay, give us more space. So how to get rid of this, okay? I just said, if we add these together, we're going to get 2a, b minus b, they will cancel, and the left side will be 2a plus 2c, which is not going to be useful. Okay, but what if I subtract them? So I take this term, like the first term, and we minus it by this term. So we're going to get a minus a. And we're going to get this term minus by this term. It's going to be b, positive b, minus, okay, negative b. And the last side here will be c minus c. So I'm going to write it this way. Is equal to, remember, what did I do? I took these three and I minus them by this three. Because I did this to the left side, I have to do this to the right side. So the right side will be, okay, 3322 minus 2020. Okay, good. There we go. So we just have to cross a minus a, 0. C minus c, 0. Look, b minus negative b is again positive b. So b plus b is equal to this number minus by the other one. It will be 1,302. So 2b is equal to this value. So we just have to divide it by 2. 1,302. 1,302 divided by 2 will be 651, which is b. And the question asks for b, right? This unit, at the beginning, I said this is b. So 651, that means A is the right choice.